Now I don't know if some of you remember this. This is a previous video I put up of the Nexrad up in the north of Scotland. There's pictures of it on the internet. The purpose of this video was only using this as an example for what I'm about to show you in Ireland. This happened today in Ireland, Saturday the 24th of July 2014. Now this is an example of how powerful a beam these Nexrads can send out. At Stormaway there's a Nexrad there. As I say, I've put pictures of it on. It's the duplex Doppler radar. It works at wavelengths, various wavelengths, but one of the wavelengths it works at can cause precipitation, as it did here. But look how far these waves can go out. They can go out for many, many miles. One of these can virtually cover Scotland. So bearing that in mind, look what happened over Ireland today. And I want this for the benefit of the Met Office, because I'm hoping to show this to the Met Office. And just look what happens here. So now we are Wednesday the 23rd of July at 20:30. So it's 10:30 the night before. So today is, so it's Wednesday, yeah, so Wednesday, it's Thursday today, so the last 24 hours. So we're going to start this up here. Now, not particularly any precipitation. There's been some radar activity just previously, but nothing to shout about. Right, now when we play this, you'll see the radar beams kicking there. I'll go back, cross there, towards Wales. There again, there's a Nexrad down here. There's one in Dublin. There's one in Limerick. Now watch the activity around Limerick, because here you see all that sort of scaling, flashing on and off, working its way around in a circle. Now bear in mind, it's warm, there's no cold front, and there's a high, which should mean blue skies and no rain. But just look what happens. Soon as the radar hits it, I'll play it slowly here. Watch now, it kicks in here. Bang, bang. So bear in mind, folks, this is 1 second frame every 15 minutes. Can you imagine what's going on in between the frames that we can't see? So there, the Dublin Nexrad kicks in there. Limerick's starting to warm up and brew. The waves are coming out. Bear in mind the one in Scotland. In between this, these wavelengths can be shot in virtually any direction or all directions at the same time. So again, hits it again. Really big. Now it's hit. It's working on it. Precipitation kicks in. Not just 1 or 2 millimeters, not 4 to 8, not 8 to 16, but 16 millimeters plus, in the middle of nowhere with no cold front. So what's causing precipitation? Deliberate wavelengths, weather manipulation, geoengineering, folks. Geoengineering, deliberate. There, maximum precipitation. Have you noticed how quiet the Nexrads have gone now? Because precipitation's kicked in, they have done their job. Okay? And then it disappears, completely emptying all virtually the rain out of the atmosphere. There you go. There's an example of it. Now, you don't get a cold spot causing precipitation in the middle of a hot spot, the middle of nowhere. We normally, in the past, had a cold front moving in, where the cold air hits the warm air. And then you had rain wherever the cold front hit the warm air, and you'd get the odd thunderstorm. Now we get lightning storms with no rain. We get thunderstorms in the middle of no man's land where it's red hot. It isn't natural. It's not normal. This is the same period of time. This is in the English Channel. You'll see one round Falmouth area. There's a Nexrad there. There's one on Guernsey. You'll see the big rings kick on that one. These have already been hit. Can you see that row of dots there? It's not usual to have rows of dots, and I'm going to show you a line that goes right from virtually Falmouth, the Channel, right up to Ireland in a straight line Folks, we don't have clouds that go for 300 miles in a straight line like you could draw them with a ruler. This is manipulation. Deliberate geoengineering. So there you go. Look at those Nexrads kicking in. The one on Guernsey. Now bear in mind, you've got two lots of rings. You've got one there in the centre, these rings round here, one on Guernsey, and the Nexrads work together to cause precipitation. There, you can see. Again, remember, this is only 1 second exposure every 15 minutes. I would love to see second by second of this. There's your ring. There's your Nexrad kick in. All those circles down in Cornwall. Okay, you'll see Guernsey kicking in as well, crossing over. And where the lines meet, precipitation takes place. Heavy precipitation. There's your centre focus again over Cornwall. Again, you can see all the wavelengths working away, hitting it, working it. Wow, do you see that? One straight line just appears there in the middle of nowhere. There. Wavelengths hitting it, precipitation's happened, bang, straight line from Falmouth straight towards Guernsey. Again, more hits in that straight line where your beam comes out. You've got a straight line there, curling. And then over the Nexrad station, and where Guernsey's hit it, you've seen that line come straight down from Guernsey. Let me go back. See the line go from below Guernsey to St. Brie? That's not normal. You don't get rain spreading out like a finger. Okay, and now the Nexrads kick in down in Plymouth, and then you see that circle there hit, and then suddenly in the middle of nowhere below Taunton you get another line hit. There, just appears straight there. Bang, the dots. And you see the swirl manipulation of Guernsey. Just below Guernsey, watch that spot closely there. Slight anticyclone, which is, they can manipulate it to spin. They spin the air from Nexrads. There, anti-clockwise rotation. And the precipitation just below. We're going to look at main Europe there. But let's just play that through as you watch it. They're controlling and manipulating precipitation and ionising the air. Particulates then kick in, cause condensation, and you end up with rain. Right, let's just pause this one here for a minute. Now I want you to take note of that straight line that goes from the north of France straight up to Southern Ireland. Is somebody going to tell me that that is natural, that you get a rain cloud that's only about 10 miles across but stretches for 300 miles? Are we living in cuckoo land? That is not normal, and that's the giveaway. That's where some of the energy lines go that causes precipitation. Right there. There's nothing normal whatsoever about that. There's something also interesting that someone suggested to me, and I believe they might have a point. When you drive around, we see what we think are mobile telephone masts, and obviously some of them are. On those masts are a radar type transmitters. They're like tall, long, thin, what would you explain them as? They're tall beams, if you like, and they're normally in a round circle. Now, this is what I believe. Maybe this is something new to me, but I'm going to show you an example. If it's true, then this is how they will show up. So that line then alters and dissipates. It's obviously picked up on the weather chart as far as precipitation, because you had that long thin line showing up on the radar. But where it rains is the shape of the radar as well where it hits. But watch England mainland, and when all the radar kicks in, these can be activated obviously via a computer across the whole of the country instantly within a second, because they're all linked. So when they want additional manipulation, so I'm just trying to bring it up, and you'll see the whole of the UK light up there. Now, can someone explain that to me? How come all of the whole of the UK, if those are the transmitters, you've got all this radar right across the whole of the United Kingdom, showing up. And I believe some of these are them small transmitters that energise the particles to help out on the energy in the atmosphere to manipulate the weather. I can't see any explanation for it at this time. If I turn out to be wrong, I apologise. I don't think I am. I would be interesting to point out and match up all the transmitters that we know that partly are to do with mobile phones, and I bet you they'll line up with every one of those dots across the country. But the main thing is the Nexrad wavelengths. They do cause precipitation. They always kick in before the rains, and it always rains where the beams hit. I don't know how much evidence you need to prove that case.